Welcome to IMD's Industry Insights. We'll be right back. Before we get started, I wanted to remind you to hit that like button. And also, if you want to subscribe to our podcast, hit that button down in the bottom right corner there, and that'll get you subscribed. We do appreciate you being here. Let's get started. Welcome back. Tracy Bellamy has more than 30 years of experience in the fire protection industry, including not only fire suppression system design, but also fire hazard analysis, fire safety systems testing, and fire inspection. Tracy, thanks for being with us today, and I'm sure I missed something in the introduction, so please, if you'll introduce yourself, tell us a little bit about Telgian, and we'll get going.
Okay, I appreciate it, Brian. My name's Tracy Bellamy. I'm a fire protection engineer. I'm the chief engineering officer with Telgian Engineering and Consulting. We're a fire protection engineering consulting firm that does work both nationally and internationally, addressing fire protection, life safety type hazards of any type, and risk assessments that are out there. I've been doing this for about 35 years. I guess you can tell there's a little bit of gray in my beard that I've earned over the years out there, but I do appreciate you having me on today and look forward to talking to you.
All righty. Well, Tracy, with all the new technologies coming out and materials as well, you've got the lithium batteries, and you've all kinds of different stuff that's being stored, and they're causing new problems for the fire protection industry. Could you explain what those materials and technologies are that may be causing that problem?
Absolutely. I kind of want to go back a little bit. I guess, some of the technology we use today and some of the design basis we use today are 50 plus years old. Some of that information that was done was 50 years ago, and the types of materials and the way we handle those materials was quite different back then. But we still have some of that information resident in our codes and standards, particularly NFPA 13, that addresses fire sprinkler design. And people rely on those standards quite directly and heavily in order to develop their design criteria for protection of these items. And we haven't really advanced totally to where we should be in terms of what materials and the material handling type arrangements that we have out there. I know as far as materials, you mentioned lithium-ion batteries. There's a tremendous amount of energy stored within these individual batteries. And when you have a fault condition, you can have a substantial release of energy that's sustained that we just have to address a little bit differently out there. That's certainly one of the items. The other that's probably most prevalent in materials out there is the change from ordinary combustible materials such as wood, paper, natural fibers, and things like that used to be quite prevalent for us, to synthetic materials, Group A plastics. Group A plastic is essentially a hydrocarbon or a solid hydrocarbon, solid gasoline, if you will, and the heat release rate associated with those materials is well above those associated with those ordinary type combustible materials that a lot of our basis in design were built on. And plastics are prevalent in our world. I mean, I mentioned the mattress. We all sleep on a mattress is probably substantially constructed of different types of plastic foam materials, where it used to be cotton batting and inner springs and like that. The amount of those materials is just ever increasing out there. And then from a material handling standpoint, we used to have limits, practical limits on how high we could store and how much material we could store in a facility based on the available material handling methods or equipment that we might have. In original stuff, I mean, we were limited by manpower lifting and placing loads onto things, and we had lift equipment that would lift things, but we had to have aisles available for them, and then we had limits on how high we could place that stuff and how dense we could place it. But now we've got robotics. We've got automated storage and retrieval systems that extend that ability to store within a space well beyond what we used to have. We eliminate aisle spaces or separations between piles of product, which further increases the risk of fire spread from one pile to the other. And in some cases, we have essentially no aisle space. We have robotic systems that can literally fill a space entirely with material. And from an efficiency material handling standpoint, absolutely wonderful idea. It's best use of space. It's speed of delivery and all those things. But we're stuck now with trying to figure out what risk we have with that and how to protect it. I often tell people, I'd rather let's try to figure out the fire protection impact of this and build in a solution up front, as opposed to what we normally do is allow that problem to develop and come find us rather than us try to find the problem and develop a solution up front. That painful reality of letting that problem find you could be loss of an entire facility. And some of these facilities run in the range of 1 to 2 million square feet of space, which makes that risk even greater. I mean, risk is frequency and consequence related. And when you look at 2 million square feet worth of space, it might be upwards of 50, 60, 100 feet in height. There's significant, not only economic, but practical impact. It interrupts your supply chain process completely.
Well, with all that new risk and the new technologies and materials, what if any kind of new fire protection technology is there to combat that?
I talked about NFPA 13 and 50 years ago, a lot of testing that was run for that. There is some new testing that's been run. Some of the insurance side has started looking at this more heavily. Factory Mutual has some data sheets out there that address not just storage, but automated storage and retrieval systems and a variety of things. 8-9 on storage and 834 on automated storage and retrieval. But the rank and file folks in terms of compliance have to comply with NFPA 13. And it really had, I'm a member of that technical committee or the discharge committee on there, as well as correlating that develops that standard. And we realize we just don't have the data to basically change the standard or bring it up to where it should be. But there's a lot of folks, and we're out there actively running large scale fire tests. One of the things that I look at with this stuff is say, do you really want to know what's going to happen when you have a real fire in a real storage arrangement in a real building? Let's go simulate that. As an engineer, I can, calculate and do formulas. We can't calculate fire growth in these racks and sprinkler interaction very, very accurately. We can do things, but we can't get it exactly right. And we pushed and we run substantial number of tests and have gotten actually interest from customers that now want to know. And that's really one of the things I push with fire protection is I don't mind you taking a risk. I just want you to know what risk it is you're taking. And the best way to do that sometimes is go into a test lab and demonstrate what a particular protection scheme would look like. We've actually had some customers that have run large scale tests and said, yes, that was a successful test based on the design metrics that we have been using again for, I guess, 50 years or 50 plus years now. But they said, I don't think I like that level of protection. So, well, that's minimum. What would you like to see? And we run additional tests to show that we can reduce the risk. And it's all a cost benefit type thing. How much risk what's your risk appetite? And how much are you willing to invest to try to mitigate that? But I think that's the biggest thing I'm seeing now is fire testing. I don't know that it's as widespread as it probably should be. There's only a couple places in the U.S. at Factory Mutual and at Underwriters Laboratory where you can actually run these tests. There's a laboratory in China, as I haven't been to that, but and then Factory Mutual only runs tests for their insured. So really, if you're not a Factory Mutual insured, you're kind of limited to UL. They're costly, but how much is the data worth? When you talk about having buildings as large as a couple million square feet, are you willing to take a risk on that with something that is unknown out there. But that's the biggest thing I see is us trying to uncover those risks, present those risks to the operators and owners of facilities, and let them make a risk-informed decision.
With the onset of AI and things of that sort, do you foresee that testing maybe moving into a digital environment rather than the actual physical environment?
You know, from a fire modeling standpoint, we've advanced tremendously certainly over my career, in terms of what we're able to do, in terms of modeling. We're just not there. I think it will be some time before we're there in terms of not just the fire growth, but the interaction with the water discharge or suppressant discharge and how those things interact together. I think there's a possibility we can get there. I don't see it in the short term. I'm a real believer in, even the science. We've done calculations and have beliefs of things that we think are going to happen. And I'll tell you that I've been humbled many times going to the test lab and lighting that match and having results that were both worse than or not as bad as what we might have had a belief of. And one of the things I tend to do with a customer when they ask, hey, what do you think will happen to the test? And I kind of almost flippantly say, I don't know. Not that I don't know, but I want them to understand I have beliefs and ideas and engineering reasoning that leads me to a thought, but I know it's not perfect, because there are things we all can learn every day. And I think that is something that's coming in terms of AI. But I don't know that it'll be quickly. And then we have to kind of validate, we have to say, okay, here's what the model would tell us. And let's run some tests to make sure that we are hitting the mark consistently out there. I think the biggest concern I have is if you get it wrong, what's your consequence? And it could be in the world of material handling in these large logistics centers, it could be, $1 billion+ type losses.
Fire just has so many variables that contribute to how bad it is or how it spreads. I can see what you mean. AI is got a lot of catching up to do to get to that point. Our at Industrial Machinery Digest, our main audience is small to mid-range manufacturers, warehousers, that type thing. One of the, of course, new technologies that a lot of them are trying to get into is additive manufacturing. I know it's mainly plastics. They're getting into the metals, but it's mainly plastics. How does that contribute to what you're concerned with?
When you introduce plastics, and there are a variety of different plastics that are out there, whether it be polypropylene or polyethylene or polystyrene or polyurethane or PVCs, they're not all that bad, but you have to look at what those plastics mean in terms of fuel load. They are a significant increase in fuel load beyond certainly metal materials. If you were doing metal working, certainly there's a very limited hazard associated with the metal itself. You might have, in a process, you might have hydraulic fluids or something that's more prevalent. But when you introduce significant amounts of plastic, now you change the risk. One of the things that I think we all need to be concerned about in terms of protection, particularly sprinklers. When I look at a building, I go into a building and a facility is operating, it has sprinklers in it. And they're doing metalworking, let's say, and they decide, hey, I think we could do some add-on work here. We can do some plastic molding or blow molding or injection molding or whatever they want to come do. And they've got piles of these materials in the facility. And the thought is, well, we're sprinklered, so we're protected. The problem is not all sprinkler systems are built the same. You have systems that are designed to deliver, certain smaller quantities of water to, and maybe a sprinkler head that has a 1.5 inch orifice, very small orifice. We've got sprinklers out there now that have 1 inch or even 1.25 inch orifices on them, delivering, at 100 PSI, they could deliver 250 gallons, 280 gallons a minute, lots and lots of water. So the belief that I think we have out there is I am sprinklered, therefore I am protected. And that's not, that's a false statement. It bothers me that people have a false sense of security that I do have sprinklers. So if I do have a fire, it's going to take care of that. I think there's a general belief that the sprinklers will come on and the fire will just psh, and go out and it's kind of over. But if you see some of these fire tests, it's a battle. The fires, particularly with the plastics, are just wildly aggressive. I've never had an individual who has attended a large scale fire test who's ever said anything other than, wow, that was faster, bigger, worse, you name it, than I had expected. I think we're all lulled into some belief of knowing what a fire looks like. There's fire service people who understand it absolutely, but the lay person out there sees what they see in movies or on TVs and they think, we got plenty of time. But we ran a fire test the other day, and 40-foot tall building, and in a minute, 1 to a minute and a half, you have fire reaching a ceiling 40 feet in the air. That's really, really, really fast. Much more so than you would think. People think I can go get a fire extinguisher, or the fire department will be here in 7 to 10 minutes. That's not something we need to rely on. We need to have better protection up front.
When you say these buildings are sprinklered, I'm sure the majority of them are water, but are there other, I know I worked at a TV station for a while, and our fire protection was halon.
Yep.
Of course, you didn't want to be in the room if that went off, but it wasn't going to be water. Is there anything like that can be used in manufacturing or warehousing?
Well, in warehousing, in large scale warehousing, most prevalent is water, is fire sprinklers. The water's cheap, it's available, it's a very, very good suppressant agent. You could possibly use high expansion foam. We have used high expansion foam in a warehouse facility. The problem is once it goes off, it fills everything. So everything's going to get foam on it. And could that be an issue out there? I think we had a large alcoholic beverage distributor that they were requested to put foam in a large barrel warehouse with distilled spirits. And their concern there was if I have a small fire and I dump the foam and it fills this entire warehouse, we could do that. That you would end up with potential contamination of the product, and they will have to destroy or throw away the product. They said that the fix is no better than the problem. The solution's no better than the problem. So I think there are times where we have to think about things like that. Gaseous agents, probably not. You're too expensive, out of the realm. One of the things that we're seeing a lot of interest in is oxygen reduction systems. Where you basically have systems that will deplete the oxygen level in a space to a point where you cannot support combustion. I think there's a lot of interest in that. There's some good stuff out there. I do know there are concerns that folks have about ability to enter the space, either by your own personnel for maintenance operations or emergency personnel to enact some sort of rescue or something like that. So there's some things that you'd have to address or deal with there. And then there's maintenance over time that you have to make sure that, if you leave the doors open or the system stops, you could be completely without protection. From a manufacturing standpoint, there's a lot and it's more localized stuff. Like you have a individual process that might represent something quite significant in terms of hazard, maybe a flammable liquid spray operation or dip tanks or something like that. Put in a special hazard, maybe dry chemical type protection system or CO2 system right over that item. Similar to like you mentioned halon. Halon we aren't allowed to use anymore because of the environmental impact and stuff. But other gaseous agents are out there in the clean agent category to protect things like computer rooms or space. And I'm assuming that's around some very sensitive equipment concerned that, hey, I don't want to dump water on this. And all of this comes down to cost benefit. How much does it cost? What protection does it give me? And is that protection, like the foam thing? If you dump foam and you destroyed my product in the entire warehouse, me seeking to save the value of the building was this much. compared to the value of the product that these folks made. But we're always on the lookout for we've looked at combining water with some sort of chemical agent in the water to give it a greater ability to suppress or control a fire. That's still out there on the cutting edge that we're trying to tickle at every day to say, what is the next best thing that we can do out there to better protect ourselves.
Well, Tracy, if any of our listeners would like to engage with Telgian to see what their facility needs, what's the best way to go about that?
They can certainly reach out to any of our offices that are out there. I'm in Atlanta. They could certainly reach out to me. Could call me or email me. My cell phone number 61, and the email is Bellamy, TBELLAMY @Telgian, and that's TELGIAN.com. Or you can go to the website or look us up. And if you got just a quick question you want to call me, I encourage people when I speak or teach, if you got a quick question, call me. If you said, hey, I'm wondering if this is okay or that's okay, and I'm happy to answer a quick 5-minute, 3-minute question. It doesn't bother me at all. I've had folks that'll call and spend 45 minutes telling me a huge convoluted story and say, okay, is it a yes or a no? And I'm thinking, oh my gosh, that's a lot to think about. Thought costs money. I'd love to engage you in something, but I really endeavor to make sure we get it right, because I know folks out there, when they talk about fire protection, it just costs me money. It's aggravating, but there's a purpose here. And if we are hitting that purpose mark and we save just one building, that's out there. And most times we don't hear about our successes because it's a small fire. It gets handled, it gets addressed. What you hear about is the disasters. And I got to believe that those disasters make people believe fire protection is just a joke. And, when you go out and do it wrong just because it's cheaper, and most of our folks out there in the world want the cheapest fire protection they can get away with, because we don't see it every day. We don't have fires every day in our facilities. But I'd be happy to help in the very most basic way of, hey, yes, go to this standard, go to that standard. Or if you want to engage on a full project, fire test, design, whatever, we're open to any of it. So I appreciate you having me on.
Well, Tracy, I appreciate you being with us, and maybe we can touch base in the future, see what new stuff's coming down the pike, both in fire dangers and fire protection.
Absolutely.
All right. Well, thank you, sir.
Thank you.